Do we have anyone willing to take notes today?
I can do it.
Thank you, Anthony.
Hey.
All right, I guess let's get started with status updates. Oh, Jesse is also, he's having he's busy, so he may also join. But anyway, I can give a quick update. We are kind of closing in on the issues that are open for life cycle 12.0. There's one sort of big question that we need to answer about how we're going to architect some code to solve a tiny problem that it should be tiny, but it's challenging to solve. So once we figure that out, I put that on the agenda, but we should be able to proceed with shipping our release candidate. And I have some more thoughts about how that might go that I put on the agenda. That's all for me.
I had a question because I was thinking about, this is sort of related to this tiny issue, to sort of the schema change in stack toml, right? I was wondering if we've thought about how this affects builders. Like right now, stack toml is baked into builders. Does that mean that no one will be able to use the new API without, Pack changing the builder logic to create this file? And if Pack does change that logic, does that mean you won't be able to use new builders for the older APIs? I feel like this is getting into one of our problems of API overlap that I hadn't really thought about until this moment, that the stack toml schema changed sort of changes. Like right now, you can use any builder with any platform API, and that might not be true now.
I don't think anybody thought of that until now, so we should talk about it.
Yeah, I don't know, like, I don't have a great idea right now. It like dawned on me recently that this was a problem, so I wonder if like we might all need to think about it and then come back together with ideas.
Anybody else have updates to share? Not, we could move on to release planning, which we kind of talked about. I could share my screen if we want to just take a quick look at the milestone. I don't think much has changed since last week, but just go ahead. Okay. So these are all the open issues in the milestone. This is just we need to open a question. Actually, Jason, maybe we can ask you. We were going to ask a question and GGCR. I'll throw it on the agenda so that we can circle back to it. But I think for the purposes of release planning, hopefully doesn't cause us additional work. And I'm working on this chore as we speak, so it's all in motion. I think the big one that requires work is this, which we touched on. There are changes to the schema for stack toml and the new platform API, which has led to a cascade of changes in our code and may require additional work on the platform side as well, or somewhere to handle this builder problem. So we'll get to that. Any other comments on the milestone before we proceed? Okay. All right, so I guess let's dive into needs discussion, I think that might be circling back to, we're gonna ignore the stack pack ones for now. So convenient that you're here. I had an action item from the last of these meetings to kind of reach out, because we have some folks who are trying to use Buildpacks, and if they do not provide a trailing slash when they configure their secret, it all like just blows up because of the way we're doing the matching. And I kind of dug into the code. If I follow the trail right, I think, you know, this trailing slash is sort of a hard requirement. And I believe there's code in Docker as well. So we were wondering if there's anything that could be done to make this a friendlier experience for users, because they get very confused as to why they're not able to connect to their registry with a secret that looks correct.
Right. Without completely knowing the full history of this, I'm sure that we could do a better thing in GGCR about this. And even something as simple as like, if there is no trailing slash, add a trailing slash and keep going. I will talk to John, who I think knows more about the spec requirements, or at least behavioral, you know, de facto spec requirements. But this off the top of my head, it seems like this should be easy to fix in GGCR and pick up. So yeah, thank you for bringing it to our attention and for not doing what I think a lot of people would do, which is to paper over it before contributing it upstream. So definitely thank you for letting us know, and we will take a look and let you know. Actually, I'm gonna file an issue on GGCR now to talk about this. I'll CC you, Natalie, or anyone else who wants, and reference this issue. 608.
Thank you. I guess with that, that kind of concludes the ones that we had for needs discussion. Although I think there's quite a few discussion items which maybe we could jump to. We usually leave some time to kind of just say what are the open RFCs that relate to implementation. I think all of these are actively being talked about. We just had where they were all mentioned in some form. So I guess just encourage everyone to keep an eye on the discussion that's happening.
Sorry, there's the core one I opened this morning for.
Oh yeah, we don't have.
Generally, we said only one label per. It's like you can't be core and
Oh.
implementation, and so you don't see it here. But that's a really big change for folks here. It's like mostly lifecycle work if we do that. So just as an FYI, I want to take a look.
What if I switch it over to implementation, actually?
Yeah, I was thinking that. Ben said we're doing the thing, but
I think we usually just leave core for like governance and other things, and implementation usually for the big spec changes, although obviously core team owns the spec, so it's not clear why we do that, but I think it might be more useful.
So that's this RFC, which is like, it's, as you mentioned, quite a sweeping change. So yes, we should all weigh in on this one. So I guess with that, I think we can move on to our agenda. I know Micah added this here, but Jason, I believe you opened this issue. Do you want to speak to it?
Yeah, so I don't exactly remember how I started looking into all of this, but I noticed there's a long-standing lifecycle issue for supporting ARM, and I just sort of got curious about it, and I think it's dangerously close to being possible to support ARM in lifecycle. It's even easier, I think, to support ARM in Pack and possibly other things that might want to support other platforms. but sort of that spiraled and ballooned into taking a look at how the image is actually built in the first place. And it seems like it's a lot of the logic is in the makefile. The makefile builds one Linux AMD64 binary and then one Windows binary, Windows AMD64, and then does sort of parallel logic to assemble those into to images and then to stitch them together in the release GitHub action into a manifest list. I have quite a lot of experience doing that sort of thing. That's exactly what Co does. Co basically is sort of like Buildpacks, except hyper focused on Go only. And then it also has this arm where it does some YAML stuff. I don't really like that part. But the idea for Co is that if you have a Go binary or Go source and want to build it into an image and you don't depend on CGO, we can do that for you very efficiently, and we can do that with multi-arch images, multi-platform images very easily because of Go's cross-compile support. So the idea is that either Buildpacks lifecycle could use code, literally use code to build the images, or just standardize on something like what code does and do cross compilation. I think the Windows image is actually only built on a Windows machine right now, which might complicate your release process. It should be, in theory, it should be possible to build a multi-arch image from whatever platform because it's just a Go binary. Asterisk, you currently use CGO, and I don't think you have to. I forget which issue that is to use 630, lifecycle 630. If you do that, then you can much more easily take advantage of Go's cross compilation support. And I think really at least slim down. I tried to say both of those words at the same time. Your release process into sort of an easily reproducible, stamp outable process across all architectures and OSs. That would make ARM support easier, but that would also like incidentally make S390X support easier and PowerPC easier. I don't know if that's all interesting to you, but yeah, so I think Micah mentioned that the whole reason I'm here is because Micah mentioned this meeting was happening and this would be a good sort of set of people to talk to about this. I don't know. Does anyone have any thoughts? Does anyone think this is a good idea, a bad idea, meh idea, needs more investigation?
I think there's a lot of complexity with the set UID stuff that led to the inclusion of CGO that has to do with bugs in glibc versus muscle versus, I think Emily, you probably have.
Yeah, there's a reason we did this, use CGO instead of just using the syscall library. I don't 100% remember what the reason was, but I think I can filter through the history and find it out. But we definitely didn't want to use CGO. It would be fun to not use CGO, but I think there was a hard blocker on just using the Go standard lib for what we were trying to do.
Interesting. Okay, that's good to know. I suspected that was the case because what kind of monster would use CGO when they didn't
like
have
just
to?
for fun? Yeah.
But yeah, but I thought just in case. I mean, if it's if we can root cause that to some issue in like the syscall package in Go 1.11 that is now fixed in 1.16, that would be ideal, right? Maybe we don't need to use it anymore. But oh, maybe was that it? This set UID multi-threading issue. I'm not sure. Certainly, I think we all agree it would be super nice not to use CGO, and then if we do, I would like to propose that we streamline the release process so that it can just be like 4 arch in these arches for OS in Linux, Windows, build and stitch together an image, I think that would be awesome. But obviously you all know way more about this than I do, so I'm at your mercy.
I'm happy to hear that this issue has been solved. And this does look like the issue we had originally, because we could strip out Seago, and like right now we have to compile in an Alpine, because something
Yeah,
with
yeah,
muscle
yeah.
versus glibc, just using Go, like everything would be so much easier.
Yeah, I saw that in the release process, and I was like, oh no, what, why is this? No, but I assume there was a reason. If this is the reason, that's great, because that means we can not have it anymore. If there's any sort of like test case that I can run to prove that building with Syspol instead of Seago works, that would be ideal. I lost the thread on why that change was originally introduced. So Emily, maybe that would be helpful to have. But
Yeah, I'm like, it's slowly coming back to me. I think when we use the Go implementation, the dropping privileges only worked for a single thread. So if you ran one of these builds that has to like start as root and then drop privileges, some threads would end up with the wrong privileges. So I don't think we had like an automated test for this, but if you just run enough builds in a row, like you'll eventually see it, or you won't. So you'll never know for sure it's not there. You can say it's statistically likely that it's not there if it succeeded this many times.
yeah. My favorite kind of bug, one you can never completely prove, is fixed. Great. So I will attempt to not reproduce this bug with the Syspol change, and then if I think that change is sort of nice, whether or not we end up rebuilding the release process. But this being out of the way would make it possible for the release process to be a lot more sort of standard across OSs and platforms. I had originally proposed this, or phrased this proposal in terms of literally adopt the tool Co. And I think as I've thought about it over the last week, I think it's probably not a good fit exactly, because you'd also do like symlink stuff to make the lifecycle binary available as detector and analyzer or whatever. I don't feel strongly that you need to literally exactly use Co. But
I think the reason we can't use Co literally is the same reason that we weirdly can't use Buildpacks literally to build this, which is there's this elaborate file system based API that needs to happen inside this image. So you like really have to lay things out very specifically. It's not, it's not just a Go app that runs. It's
right.
Yeah.
I am curious. I mean, this is purely curiosity and not. It doesn't need even to be answered. I'm curious why it seemed like you have this lifecycle, single lifecycle entry point binary that you symlink to many locations, and then when it runs, it says, "Am I being run as reflector or analyzer or detector or whatever?" Is there a reason you chose to do that instead of to just literally build 8 whatever binaries that
makes the image smaller?
Yeah, fair. Okay.
That's the only reason.
There's also the creator is like a way to execute all of them at the same time as one binary, and so it made it feel a little more cohesive. There's one that'll string out all the like different parts of lifecycle together as in a single execution, so you can do like a pack build in a single container. So I think that made it make more sense at the time.
Yeah, no, there's no judgment there. I just thought it was interesting, and I'm sure motivated by something. Image size definitely makes sense. Aesthetic streamlining also makes sense. Okay, so I will try to see if this Syspol change is good, and if it is, we can get it in, and then if that goes in, we can see about trying to streamline the release process. At least streamlining it for the 2 you have today would be great. If streamlining it makes it much more easy to add 2 or 3 or 4 other options, that would be even better. Full disclosure, I intend to use this in Tecton. We also use, we have a lot of users who want multi-arch support and increasingly annoyingly Windows support in Tecton. And so the more Buildpacks supports this, the better Tecton will be, and the better Buildpacks will be. So that's wonderful.
That when you say Windows support in Tecton, is that Tecton scheduling task containers onto Windows K8s nodes?
Yeah.
Interesting.
Yeah, so thanks. I don't really have anything else, but I will happily cede to the next discussion topic if there is one.
Thank you for looking into this. This would be cool. So we have 3 more topics. I think we should maybe just like, this one is like, I want to look at some code. I want people to tell me what to do with this problem. It's probably a longer discussion. So maybe we could get the first 2, the last 2 out of the way. I added them all. So for the next life cycle, we're planning to ship a release candidate. We want to hopefully avoid some of the mistakes of the past and have like some sanity checks on our stuff in a variety of environments. That's the dream, right? Before we ship the final one. When I floated this with the Keto team, they said, we'll happily consume a release candidate, but please don't tag it with a semver tag, at least, sorry, the life cycle image that we publish, please don't tag that one with a semver tag, because we'll mistake it for a real one and pull it into our production pipeline. They've since fixed that issue, right? So they can now properly tell if it's, there's like a -RC or whatever, that they won't treat it as a fully released one. But it kind of got me thinking, like, who else, right? Who else out there is, has automated pipelines that might trigger on a new lifecycle image? And, like, if we just all of a sudden start shipping these images, these release candidate images, are we going to create problems for other people that we don't know about, right? So I don't know how valid is that concern, but when I created the GitHub action to actually create the release candidate, it will create a release candidate on GitHub, right? So you'll get that GitHub release page with the tarballs are all, versioned with an RC, but it won't actually retag the lifecycle image. So you'd have to know the commit SHA and go pull it, deliberately, which, I don't know how that workflow is. And I was also thinking that, even a release candidate on GitHub could confuse some people, right? You never know what logic people have to pull in these artifacts. So just wanted to get everyone's thoughts.
There's a part of me that says we shouldn't worry about it too much. Like, I think the thing that we shouldn't do is, I know, like right now when we publish semver lifecycle images, when we publish a new one, we also move the latest tag. Definitely don't want to move the latest tag to point at the RC. Other than that, I feel like people can deal with it. Like, I know we've had situations where we're consuming automated dependencies and, other types of automated dependencies in a bunch of situations. And maybe someone doesn't get the logic correctly right for how someone starts publishing an RC, but hopefully, a pair of someone is looking at things before things get shipped out to users. And I think this is a standard enough way to do things that I don't think we're really inconveniencing people. Not saying that nothing will break for anyone, but I think it's reasonable.
Is the Keto team doing something besides looking at the latest tag? Like,
Yeah, so actually, Emily, your comment, it got me thinking, I don't know if we currently move the latest tag every time because we publish a new image for every new commit to main and the release branches. And so we might actually be updating the latest tag already. Let me just see, where do I get latest?
it's usually how people pull for, new images, fortunately.
See, these are all pushed, 3 days ago. Can I just do what's latest? Oh, last pushed a month ago. So that must be done in our GitHub action that retags. Okay.
Release
That all sounds same, right? That's why
Yeah.
we shipped a patch a month ago.
Yeah. Yeah. If I look for,
there is a way to get tags back, and then you could semver parse the tags and then try to figure out the latest thing. If people are doing that, that'd be really interesting to hear about. But I don't think I've seen anybody do things other than.
I'm not. So, I worked on the Java stuff and it sort of has its own automation that's different from the other build packs. But I know how a lot of the image automation works on the Java side. It's basically, using Crane LS to get a bunch of tags and then sorting them and then picking the latest one. So it's not just using latest all the time.
Interesting.
so maybe we could tag the lifecycle image with, 012 0-rc.1, but we don't update the latest tag. And, some people, like the Paketo team has already fixed this, but if somebody didn't update their logic to exclude release candidates, they will find out.
I think if you're gonna list all the tags and then sort them and then pick the greatest version, then the onus is definitely on you not to pick up RCs. There, it seems like that's if you're already implementing that custom logic.
I mean, we can do our best to publicize this, right? To let people know that this is happening. A message in the general channel or something. Okay. Having it tagged with the version of the lifecycle, that'll make other things simpler and it'll probably make it easier to actually use that RC image. So right now I was putting a little note in the release notes, like go here to find the image associated with this binary, but that's not a good experience. Okay, I'm glad we have direction on that. And then the other thing that I wanted to discuss, this is just kind of like conversation that's been happening among various people, but do we need to have this meeting every week?
Apologies, I have to run. I'm like, yeah.
Hi, Emily. Oh no, I wanted her input on the code, but oh well.
On the cadence, I'm trying to drop my platform maintainership because I don't do very much on that side, but I still open RFCs and kind of occasionally do things around the lifecycle. So I'm trying to show up to more of these, or like want to pick this sub team and show up to it, if that makes sense. So biweekly cadence would definitely be better for me because my calendar is terrible. If you're looking for votes, but I think Emily's feedback would probably be more important.
Well, we'll leave this open. I can bring it up again next time. I also think that it's good that we touch base, in person every so often. Like, don't want to lose that, but I'm not sure that a weekly cadence is really necessary. And we spend a lot of time on the updates, and it's like, it doesn't change a lot week to week. So anyway, we'll bring it up again. In the time that we have left, I would love to, I know Anthony's had a chance to look at this code, but I'd love to kind of just talk about this problem that we're facing. which is, right now, when you think about the TOML files that we're using for, platform communication, a lot of those are just represented. I mean, all of them right now are just like bare structs that we marshal into and out of, or, we might construct on the fly. And we're currently making the first non-additive change, in a while for the stack TOML in between. So if I pull it up, Buildpacks spec, and then just look at the platform side. Here's stack TOML as it was, right? And then if I go and I look at this same one on the new branch, right? This is a non-additive change. Oh no. Okay, so here that you can see both of them, right? What happened? Did I totally misunderstand what was going on? Oh, no. Sorry. No. It's analyzed. Oh, then Emily's builder concern goes away too, right? I was wrong, but actually, I think that's still a concern, but let's talk about this. Analyze. Okay, yeah, so here's how it was, and how it's going to be in the future. And so, having a bare struct is like, it's no longer, simple in the code. And we've talked about various ways forward in the past. We've said, what if we had one struct that held all the different ways that you could represent the data, and then you just have some sort of like validator per API that, checks that the data came in the format that you're expecting it. That's how we went in a previous PR. We had like an encoder decoder, which I think it actually worked out pretty well. So maybe that's one way. But then when you need to get the data out, right? When I need to ask, okay, give me the image that was analyzed, you have to know how to refer to it, right? You're going to either do .image for the old API, or you do .previous image for the new APIs. It's like kind of still messy. And so I spent some time. I was like, all right, how do I want to solve this? And I made a PR, which has many changed files, because I also had to move some stuff around. And so I just want to go back and get the interesting ones. Just move this here. So if you look at let's go to platform. What did I do? So, and I also recognize, I tried to show this to Emily in about 15 minutes a couple days ago, and she was like, this is a lot, right? So I don't expect someone who hasn't read the code to kind of know what's going on, but I made an interface to front the struct. I put it in this common place in the platform package. And I made this, we can ignore this for now, some complicated interface to allow you to build up the struct while keeping it platform agnostic. And then I moved all of the bare structs, right? Because I didn't want to have to you could make infinite interfaces, right? I wanted to be able to return a pointer to a concrete thing without having to have that also be an interface. So I just moved all of the bare structs into this common place as well. And then what I did is for the individual platforms, wait, so many of them. For the individual platforms, right, you have this okay, more the builder stuff for now. You have this, here's the bare, whatever, here's the struct that holds the data. And then I have this it implements the interface, and for the fields that it doesn't care about, it just returns empty stuff. right? Previous image and previous image metadata being the stuff that the earlier platform APIs care about, right? And then it's similarly for the, oh gosh, the newer platform, right, is going to have, you know, it's going to implement the interface and it's going to return more stuff because it holds more stuff. And that's the essence of the change, you know. However, it's like, if you ignore, I mean, if you ignore the 54 change files, which was like me moving stuff around, it's just a lot of like boilerplate. I know Anthony had some thoughts about this builder pattern. I just didn't know, because you have a couple places where the analyzer, like, it needs to build up the struct and then it calls write toml on that struct. And it's like, you don't know, it's got to work for all the platforms. So I needed some mechanism to like keep that struct private, but also, so it's just like, there's a lot of code. I didn't enjoy having to write all this code. I don't want to have to write all this code for every single file, you know, if we end up changing, like, I don't know, group toml or something in the future. Like, this is just a lot of like boilerplate, it feels like. At the same time, it works and it makes sense, you know. So I'm like, oh, I you know, when you read the code, it's like, oh, it's very clear to me. If I'm not in the platform package, it's like very clear what's happening. So this is my ask for just like, please give feedback, because in some sense we're setting a pattern for what we want to do going forward. And you know, I want to get it right, because it's just been been a pain for a while.
What's the purpose of the builder pattern and for, you know, these particular structs? Like,
it might have been me just getting really excited because I just learned about the builder pattern, but it's like the individual structs. Let me see where it's used. So it's like, this is private, right? I want to, I didn't want to like when the analyzer is building up the struct so that it can write it into a toml file later, I didn't want to have like, if platform API less than blah, you know, write this struct and then write this toml, right? Like I needed a way to construct this thing outside of the package and have it be platform agnostic. So it could be, you could just have like a function that takes a bunch of inputs, right? Ignores some of them. That could also work.
Like a key thing about the builder pattern where I've seen it used before is the kind of lazy evaluation of everything. So like, if you look at like GGCR is one of my great examples of a large Go library. It's kind of close in the space that, you know, does some similar things to what we do. And I think it uses builder pattern a lot for like, you're going to write a remote image, or you know, like kinds of actions look really different depending on the type of image, but they all fit the V1 image interface, right? Which is kind of similar to what you're doing with the, like, you want to create an abstraction across different versions of the API that's similar. But I think they use the builder pattern more, you know, because those actions, you know, don't really make sense to occur individually. It's better if you configure your object, you know, using that pattern, and then apply all the operations at once, you know, with custom logic that pertains to the, you know, if it's remote versus if it's local versus if it's like, you know, in memory or something like that. If you're just setting struct fields, you know, and the builder pattern is like adding complexity to the kind of design that you don't like, you know. I wonder if the moving to the interface pattern, so you reduce the complexity of having to deal with the different versions at the same time, and then flattening the builder stuff out maybe seems like
Yeah.
a go, if that makes sense. But you know, it's a, like, without, it's been a long time since I've looked at, you know, what's good. Like last time I looked at lifecycle code, there weren't multiple versions of things in it. So you know, I mean, that could be terrible advice, right?
No, I'd be happy to get, I mean, it was fun to write this code, but I'd be happy to eliminate a bunch of it in favor of like a constructor that just takes like 6 things and ignores some of them if it's on the older platform API. I think that would be just fine.
And the reason it's like, so I'm thinking about the problem. You have these files and they look different for different versions, and the builder pattern is used to create structs out of the files. And you, is that right? And you don't want to, you can't really marshal because the structs could look different. Is there a way you could say like an interface I can imagine for this is like, you know, v2, or because you know the API version ahead of time, right? You're not trying to guess what the file's API version is. Is that right? So
Mhm.
like, could you have like, you know, v2 package dot, you know, create, and then you pass the file name, then it returns the struct for that package, you know, as a generic interface.
Oh, yeah, it's that, I think I have that somewhere else. Because there's like different ways that like there's different ways that we make the structs. Like sometimes we read the information from a file. Sometimes it's like we know the information and we're assembling the struct so that we can then write it to the file later. So like, I mean, this could all go away, right, in favor of like one function that, you know, takes a bunch of stuff and returns a, you know, returns the interface.
I guess, do you need a function, or do you just need a struct? And then, because all the methods on the outside are just going to set fields in the struct. Is there a reason you want the abstraction for creating the struct from scratch versus just having the consumer? I guess the struct isn't exported. Is that the problem? Could you export the struct?
I could export the struct, but I don't want to like an if else in the, like say in the lifecycle package. That's like, you know, if platform API, you know, this, then make this kind of struct. And if platform API this, make this kind of struct. I just want like the struct itself to be sort of invisible and just like, I want a data object that has these things. And the platform's responsible for like, for putting it into the struct that makes sense for that platform. And then later, this would be better if we were looking at the code, but then later in the lifecycle package, it's just like, okay, write a TOML file that contains the contents of the thing I gave you, right? Like, and I don't have to care about the schema for that file. Yeah.
Could you have a, this might be a terrible idea, but could you have a generic struct that takes all of the fields, right? Or that takes the format that you want to create, and then have all of the individual version packages consume that struct, and then turn that struct into the version specific things. That way you don't have to use an interface. You don't have to use like a pattern that requires code outside of the package, if that makes sense. From outside of the package, it just looks like I do normal Go things. I build a struct out of fields that I understand, and then that struct is then translated into version specific structs.
So you're saying casting, right? Essentially, cast it into things of different versions.
Yeah. I mean, like the cast would be, you know, manually implemented in the package, right? It's not like just like a direct typecast or something like that. But yeah, like have a struct that is the generic version that then can turn into a version specific type. And you probably wouldn't create a persistent instance of it. It would be like you call, you know, vo0 dot new analyze metadata, and then you pass analyze metadata config, but that config doesn't live in the package. In the version package, the config lives in a general package, and then the result is the versioned instance of the struct.
Then how do I get stuff out of that struct? So if I want to like later like introspect on, well, what was the previous image, right? I don't want to have to know that it, you know, in one version of the platform, it lives in this field on the struct, and in another version of the platform, it lives in this field. Like, I just want the previous image. I don't care how it's stored, you know.
And maybe I either don't understand or I'm not explaining it well, I think. If that makes sense, maybe. So stepping back, your goal is to create a version specific struct, right? And you don't want a bunch of conditionals when you're constructing the version specific struct. Like you don't want to say like there's a better way to explain this. Describe how, okay, sorry. When you're using the builder, right? Let's talk about what it looks like now, right? On the outside, you know what version you're trying to create. And so you instantiate a builder for that version.
Mhm.
And then what are you switching on? Like what are your conditionals on in that case?
Oh no, that's fine. I don't mind instantiating because I can just pass in the platform API to some factory and get back a builder that is for my platform API, right?
And then
That's okay.
If you didn't do that, what's the data that you would be using excessive conditionals in order to have to deal with creating the struct that you need?
So if we have a builder that gives us back a struct with like everything, right? Some generic, like, okay, if I'm understanding correctly, like the builder's giving me back a struct, right? And it's the struct that is sort of generic to hold things for every platform, right? And then I want to pull information out of that struct. I have to know which field holds the information I care about. And therefore I need some sort of like platform specific logic in my consumer, which is the lifecycle package, right?
Got it. I'm not talking about a way of constructing the struct. I'm not talking about returning a generic struct. I'm talking about using a generic struct as input, because I thought the problem was that it's like hard to create the version specific struct with the interface in front of it without the builder pattern, because you have to switch on conditionals based on the version to construct the version specific struct. But instead, if you had a generic input struct that resulted in version specific output struct, is that a simpler way? So you wouldn't have to.
Maybe it's just easier to look at. I just pull up my ID.
Yeah.
Just get the what's this one? Okay, let's just get one. Okay, where do we actually consume this? So I just say it like with previous image. So that's like in the analyzer, right? So the analyzer needs to return, it needs to like, eventually this analyzed metadata is going to be written to a TOML file, right? So it needs to return a thing that has these properties, right? And in this package, I don't want to care what field holds the previous image. I just want a thing that has that data stored in the appropriate format.
Okay, so a.platform is a version, or a.platform is a version specific platform. Is that right? And,
yes.
But the builder but that conforms to an interface that allows new analyzed metadata builder, so that you can get different versions of the struct back and different versions of the underlying structure built when you run those commands, right?
Yeah.
So instead of using like the maybe a little more heavyweight builder pattern that requires the chain function calls and interfaces and boilerplate there, you could have one generic struct instead that just has fields that apply to all of them, like previous image metadata or whatever. And then you construct that here, and then you do a.platform create or something, and you pass the generic struct to it, and create is implemented to consume the generic struct and transform it into the version specific struct. That way you don't need the builder boilerplate, and you can kind of simplify your input thing. And maybe that gives you enough, removal of boilerplate to switch to the interfaces on the other end also.
Yeah, no, I totally, I'm not married to the builder pattern. I was just like, ooh, this will work. I think something simpler. I'm totally up for that for the creation of the struct.
That's all I meant. It's like there's an alternative to builder if you wanted to keep genericness there, but you didn't want to do the heavyweight builder part. That's all I meant. Sorry.
Yeah, no, that's fair. I think that will go part of the way toward removing the volume of the changes that were required. A lot of this is just rename stuff, right? So like this part would condense down into a few lines of code, right? And so it's really like, are we okay with this boilerplate? Because that will never go away, right?
There's a way to reduce that boilerplate sort of using embedded structs. So you can come up with an embedded struct that returns all nil values, or sometimes instead of nil values, in this case, I'd like to use, or I use a return value and an OK, and just make people explicitly check that, like, because if you're saying it's not supported by that version, you may want that information separate from the field was empty. Up to you if you care about that. But separately from that, a trick I've used in this case is create a thing called empty analyzed metadata, or empty in the name of the interface, that always returns all the empty values, and then embed that struct inside of all of your substructs, and then they inherit those methods, including through an interface, and you don't have to re-implement them over and over again with empty values. You just have to implement the ones that change.
Oh. Huh.
It's a little kludgy, sort of, but it works really well.
No, I dig it. It's just, I think the problem here is about when it gets used, right? Like when you're using a specific field, right? Like what does the code look like? Is it code going to be like if platform 06 do this, if platform 07 do that, and then how many times does that show up, right?
You wouldn't need that, because the embeddedness is just a trick for reducing the boilerplate that's highlighted there. It doesn't change anything on the outside. It's consumed exactly the same way this is, if that makes sense.
Why don't I give it a try with the suggestions that you made, Steven? Is I think, and then we can kind of revisit it. We're getting low on time as well, but I don't know. I like the direction this is going. If we could just review some of the amount of stuff, right? That makes
sense. I want to make sure I understood Anthony's comment though, too.
Well, some fields let's say a field gets renamed, right? Like it's literally getting renamed, and then the actual field name changes, right? Like it used to be in, I don't know, Buildpack string, and now it's in BP string, whatever, right? What would the code look like from someone who's consuming the struct?
I think that would just change at the level of this file that's highlighted, right? Because the field name and the JSON could change, and maybe you wouldn't have to change the name of the struct. You probably want to, or the name of the field in the struct. You'd probably want to change the name of the field of the struct too, just to match. But then it would only have to change in this file that encapsulates that logic. It wouldn't have to change for all consumers of the general piece of data, because the interface would stay the same. Unless I'm misunderstanding terribly, I'm sorry. No.
I think we would have that problem anyway, right? No matter which way we did it. If the name changed, we would have to make those changes anyway.
But you don't have to change the interface, right? And so at least the consumers that aren't affected by it.
I think I'm just not communicating correctly, but appreciate the discussion though. I think plenty of good ideas here. I hope, Natalie, you got what you want though. out of it?
I mean, I think I have more direction than I had before. I'll keep bringing this up. I think this is, sadly, this is something that's going to hold the next, we have to figure this out, you know, before we can ship the next milestone. But I'll keep prodding for input from various, you know, people, and hopefully we can get enough consensus that we can proceed. But I already with the suggestions that have been made here, I feel that you know, I can make it better. So
Sounds good. The two things I mentioned are just random ideas. Like don't feel like you need to do them for any reason. You know, Emily might have a different thing, and I don't know what patterns you're already using. So also like just, you know, grain of salt or whatever. Thanks. I got it out.
Thank you.
thank you.